So we continue with exercise 9.4, question number 15. You know that this exercise is about method of solving differential equation using variable separable form. Now 15 question onwards, you are given a differential equation and you need to get the solution. Same thing as you did in 1 to 14. So what's the question there? Find the equation of a curve. Curve means function, remember. Solution of a given differential equation in other language. That passes through 0, 0. That 0, 0 is initial condition, remember. That we are going to use at the end, you know. Initial condition. Not right now. At the end we are going to use this. Whose differential equation is this. So you are given the differential equation here. Which differential equation? Y dash equals to e raised to x sine x. Right? This is same as dy equals to e raised to x sine x dx. What I did, I've expressed in variable separable form. So we integrate it. So integrating. So if you integrate it, integral of 1 equals to integral of e raised to x sine x dx. Now right hand side, left hand side, you know it is just y. What about right hand side? You need to use integration by parts. Combination of which two functions? You know it's a combination of exponential and trigo. Record the Liet rule. You know exponential is the last function in the sequence. Logarithmic exponential. So this will be v, this will be u. We did such questions earlier, remember. So what I'll do here, I'll call this as I and I'll compute I separately, remember. Where I equals to integral of e raised to x sine x dx. Integration by parts, remember. As I told you, this is v, this is u. So by parts, if you do here, sine x will come out, integral of e raised to x minus, inside the integral, differentiation of sine. What's the derivative of sine? Cos x. Integral of e raised to x, then whole dx. So sine x into e raised to x minus, now here again, product of trigo and exponential. So we use parts again. U, v. Exponential is always the last function in that sequence, you know. So here, if I use parts, cosine will come out. Integral of e raised to x minus, inside the integral, differentiation of cos, which is minus sine. So this will be plus sine x. And integral of e raised to x, the whole dx. So this is equals to sine x into e raised to x minus cosine x into e raised to x. This will be minus. If I open the bracket, this will be minus. Now what is this? This is nothing but I. Right. Left hand side was also I. Take I on this side. So 2I equals to, take e raised to x common, sine x minus cos x, and therefore I equals to e raised to x by 2 sine x minus cos x. Here of course at the end plus c, so here also plus c. You can write c by 2 also, that's not important. Now put this value in equation number 1. Right? So if I place there in the first equation by 1, you have y equals to e raised to x by 2 into sine x minus cos x plus c. Now this is called the general solution, you know. But you are given that this curve passes through here 0, 0. So 0, 0 satisfy this equation. 0 equals to e raised to 0, which is here 1 by 2. Sine 0, 0, cos 0, you know, it is 1 plus c. So c will be just half. And therefore, required curve, that's the solution. This is in fact the particular solution, is y equals to e raised to x by 2 sin x minus cos x plus half, and just take 2 over here, so 2y equals to e raised to x sin x minus cos x plus 1. That's your final solution. Or this is a curve whose differential equation is the given equation. Y dash equals to e raised to x into sin x. We go to next question now. So here in the next question, what is given? You are given a differential equation. Find the curve passing through the point 1 comma minus 1. So there 1 comma minus 1 is, remember, what is that? It is a initial condition. So in the next question number 16, the given differential equation is this: xy into dy by dx equals to x plus 2 into y plus 2. Now, we need to separate the variables. So what I'll do, I'll take this term over here. So y upon y plus 2 into dy. And I'll take this term over there. So this is equals to x plus 2 upon x, and dx will go that side. Fine. This is nothing but what? Variable separable form, remember. This is nothing but which form? VS form, variable separable form. Now integration. Integrating. So integral of here, you know how to integrate this. We set this one over there. Y plus 2 minus 2, and do individual division. You know this. Equals to, here do individual division, 1 plus 2 by x. Right. So now you can do it further. Integrate it. You'll get the equation like this. Right. Then use the initial condition. So then what you need to do, put x equals to 1, y equals to minus 1. Use this. Get C and place this, so I'll get the required curve. That's what all in all about the solution. I'll not do it, try it. Next question. Find the equation of a curve passing through 0 comma minus 2. So that's the initial condition. Now what's given in the question? Question number 17. So in the 17 number, you are given that, what is given to you? At any point on the curve, product of the slope of its tangent and the y coordinate of that point equals to x coordinate of that point. Okay. So what's the slope of the tangent? That's dy by dx. You will learn it later on. Into y coordinate equals to x coordinate. This you will learn somewhere in the applications of derivative. Slope of tangent is nothing but derivative of a function at that point. Remember this, just you need to keep in your mind. What's the slope of the tangent? That's dy by dx. I repeat, slope of a tangent is given by what? Dy by dx. And therefore from the given data you have dy by dx into y equals to x. Okay, now variable separable form. So we keep y dy over here only. I'll take x over there. So x dx. This is which form now? Variable separable form. Then integrate it. So we integrate it. Integrating. So therefore integral of y with respect to y minus integral of x with respect to x. Or you can write equals to here. Now this is y square by 2 equals to x square by 2 plus the constant of the integration. So y square equals to x square plus 2c. Call this as equation number 1. Now you are given that this is in fact the general solution, remember. Now what's given to you? You are given that this curve passes through which point? 0 comma minus 2. So let's write that as it passes through 0 comma minus 2. So I'll put x equals to 0 and y equals to minus 2. So 4 equals to 0 plus 2c. So c becomes 2 and place there. Therefore y1, you'll get the y square equals to x square plus 4. Right? So y square minus x square equals to 4. This is the required curve. Can you just recall it is which curve? Y square minus x square equals to 4. What is this? Can you just recall? This is just for your information. This is rectangular hyperbola, if you remember, or simply hyperbola. This is nothing but rectangular hyperbola, if you remember 11th standard. That's not important, just for your information I mentioned. Okay, fine. So in the question number 18, you are given that at any point x comma y on the curve, suppose this is the curve. Curve means graph of some function. This is point x comma y, right? We are drawing tangent here, remember. What we are doing? We are drawing a tangent. So this is a tangent, for example. What is a tangent? You know that it is a straight line that touches the curve at that point of contact. Right? What's the slope of this tangent? Slope of tangent, that is this straight line, as I told you, that is equals to dy by dx. Fine. Now here you are given that the slope of the tangent is twice the slope of the line segment joining the point of contact, and one more point, minus 4 comma 3, remember. So this is given to you. You are given that this is given. From this will form the differential equation. The slope of the tangent, that is dy by dx, equals to is twice slope of line segment joining point of contact, that is x comma y, and minus 4 comma minus 3. Right? Now you recall 11th standard geometry. How do you find the slope of the line segment joining these two? y2 minus y1 upon x2 minus x1. So y plus 3, y2 minus y1 upon x2 minus x1, x plus 4. Remember, y2 minus y1 upon x2 minus x1. You know it. This is a slope. Fine. Now what is this? This is a differential equation. How will solve? By variable separable form. So I'll take y plus 3 down with this. So 1 upon y plus 3 into dy. And I'll take dx over there twice. 1 upon x plus 4 as it is here into dx. This is which form? VS form. Variable separable form. This is variable separable form. Okay, now we integrate it. We'll just integrate this. So I'll write integrating here. So integral of 1 upon y plus 3 equals to twice integral of 1 upon x plus 4 dx. Now this you know how to integrate. This is a linear function. So what's integral of 1 upon x? Log of mod of y plus 3. 2 as it is, log of mod of x plus 4. Fine. So I'll write here log of mod of y plus 3. Usually in differential equation we ignore modulus. Twice log of x plus 4. If you remember, at both the places, if your log function, just instead of c we write the log c as a constant, you know. Right? We did it earlier also, and I mentioned it earlier also, that if you have everywhere log function, you can write instead of c log c as a constant. Fine. Now I'll drop the log function. How do I drop the log function? Log of 5 plus 3 as it is. This 2 will go in power. Log of x plus 4 the whole square plus log c. Now right hand side you can take log common, so addition becomes into. So therefore log of y plus 3 equals to log of x plus 4 the whole square into c. So finally we are getting y plus 3 equals to c into x plus 4 the whole square. This is the general solution. It is nothing but, if you remember, square of one variable, so it represents parabola. Just to remind you. Now we find the c from the given condition. What's the condition? As it is passes through which point? Minus 2 comma 1. Minus 2 comma 1. So we just put x equals to minus 2 and y equals to 1. So 3 plus 1, which is 4. This is just by 1. C into minus 2 plus 4. So this is 2 square. So c will be just 1 here. And therefore the required curve is, or the equation is, y plus 3 equals to c is 1 here, x plus 4 the whole square. That's a required curve here, which is nothing but actually it represent parabola, remember. Question number 19. You are given that the volume of a spherical balloon being inflated changes at a constant rate. So just recall what's the volume of a balloon here, which is in the spherical shape, which is 4 by 3 pi r cube, where r is the radius. Why volume we have chosen this 4 by 3? Because balloon is in which shape? Spherical shape. So this is the volume of a sphere indirectly. Fine. Now what is given in the question? That's your differential equation. Given that the change in the volume with respect to time is constant. So say k, where k is constant. This is given. You read the question. Volume of a spherical balloon being inflated changes at a constant rate. The change in the volume with respect to what? Time. So dv by dt equals to constant k. This is the differential equation. We solve this differential equation first. So dv equals to k dt. K is constant, remember. This is variable separable form. Now we just integrate it. So I'm integrating. So we have here integral of 1 with respect to v equals to integral of k dt. This is just v, k will come out, integral of 1 which is t plus the constant of the integration which is c. So what are the unknowns here? There are two unknowns. One is a constant k and the other one is c. So you have two conditions in the question. We use those two conditions and we find k and c. That's what we want to do now. I just repeat. There are two unknowns, k and c. We use the condition given in the question. You have two conditions there. We find k and c and again place here. But before I do that, let me write formula for v. That is 4 by 3 pi r cube equals to kt plus c. Let me call this as 1. Okay, we don't want this now. I'll call this as 1. Okay, now as means you are given the question. Initially means what? Time t equals to 0. Initially t equals to 0. Its radius is 3. It implies radius equals to 3. So we use this and place there in 1. So by 1 you'll get the 4 by 3 pi r is 3, so 3 raised to 3 equals to here t equals to 0, remember initially, so k into 0 plus c, right? So what we'll get from this, if you simplify here, you are left with 9, and therefore 36 pi equals to c. So you got the value of c now, 36 pi. Now again we use one more condition given in the question. Now we'll get the k, remember. What's that condition? After t 3 seconds, that is when t equals to 3. Initially it was 0. Now after 3 seconds, so at t equals to 3, its radius become how much? 6. So we use again 1 and we place there. So therefore by 1, if I use 1 there, again, why I've written here t equals to 3? Because in the question it is given after 3 seconds. Initially I had t equals to 0. Now I have t equals to 3, remember. Okay. I'm putting into which equation? Equation number 1. So what I'll get here? 4 by 3 pi r cube. But what is r? That is 6 cube here. Equals to k into here 3 plus c, but c you know now 36 pi. So let's simplify this, so we'll get the k. So if I simplify this here, what I will get here? You will get 4 into here 36, and 1 will get cancelled with this, so 2 pi. You can just simplify. Equals to 3k plus 36 pi. You can divide by 3 here. So this is 12, so you will get the 96 pi equals to k plus you have 12 pi. Okay, so therefore k equals to, you will get the 84 pi. Fine. Now we go to equation number 1. So let me do here. So by 1, I'm just putting all these values. 4 by 3 pi r cube equals to, what is k? You know, 84 pi plus, what is c? 36 pi. You can cancel pi throughout the expression. So 4 by 3 r cube equals to 84. I'm sorry, t is there, remember here. I'm just putting the value of k. So you will get here 84t plus 36 dividing by pi. You can divide by 4 also and multiplying with 3. So we'll get the r cube equals to 63t plus 27. And therefore r equals to, you will get the 63t plus 27, the whole raised to 1 by 3 cube root, remember. Fine. This is the question. What's the question? Find the radius of balloon after t seconds. So you can find the r if you know t, remember. What is r? 63t plus 27 raised to 1 by 3. Cube root of 63t plus 27. If you know t, you can get the radius r. See, up to this it was quite simple. Then you need to evaluate k and c. So you must have two conditions. One is this condition, the other one is this condition. If you use this, you will get c. If you use this, you will get the k. And there, those two values are placed in one. Finished. That's what about solution, remember here. Fine. Question number 20, which is also an important example. There we need to form the differential equation first and we solve it. Now what is given? Principal increases, that is change in the principal. So first let's take principal amount. Principal equals to p. Okay. Now what is given? Just read the question. Change in the principal with respect to time at a rate of r% per year. So r% of p, of course, principal. So therefore you have dp by dt equals to r p by 100, remember, r percent. Fine. So now this is a differential equation. You can see what's a differential equation? Equation involving derivatives. Now we just express in variable separable form. I'll take p down here. So dp by p equals to r by 100. This is constant, remember, into dt. This is in which form? Vs form, remember, variable separable form. Fine. Now we just integrate it. So integrating. So integral of 1 upon p with respect to p, r by 100 being constant, I'll keep it outside, integral of 1 with respect to t. You know this is log of mod of p, r by 100 constant. This is t, integral of 1 with respect to t. You can write c or log c as a constant. I have one log function, so I have written log c as a constant instead of just c. Now I'll simplify. I'll take log this side. So log p minus log c equals to r by 100 t. So this is log of p by c equals to r by 100 t. And therefore, if I drop the log function, p by c equals to e raised to r by 100 t. If you drop the log function here, base is e, remember, if nothing is written. If I drop the log function, right hand side is exponential, you know. If your log y equals to x, then what is y? You know it is e raised to x. This is the definition. What's y here? E raised to x. So we are getting this. And therefore, finally, y p equals to, we are getting this equation. Therefore, p equals to, principal equals to c into e raised to r by 100 into t. This is main equation where c is arbitrary constant, remember. Constant comes from the integration, right? C comes from here, you know. It just comes from this constant. Fine. There is a very standard way of expressing such equations in form of exponential function. Now, first task is you need to get the unknown c. Now see, how do we get that? Find the value of r if rupees 100 double itself in 10 years. That means initially means at t equals to 0, we have principal equals to 100. Initially we have 100 rupees in the beginning. So by 1, if I use this, I'll get the constant c. What's p? It is 100. Here c as it is, and this is e raised to, put t equals to 0. So e raised to 0. So I'll get the c equals to 100. Right? Now I'll place there. Therefore, equation 1 reduced to, equation 1 becomes this. P equals to 100 into e raised to r by 100 t. Fine. Up to this, just we have obtained the constant c. Now, what is given? Rupees 100 double itself in 10 years. That is, if t equals to 10, then principal becomes 200. I hope this is clear too. Initially it was 100 at t equals to 0, like the previous question. Now in 10 years means now t is 10. What about the principal? It was 100 here. Now it becomes what? 200. So by 1, or you can use this or this, whichever you use. By 1, p. What is p? That's 200. Fine. C you now got how much? 100. So 100 into e raised to r by 100 into how many years? 10 years. So here you have into 2. I hope this is clear to you now. So 2 equals to e raised to r by 10. You can take the log again. So log 2 equals to r by 10. exponential becomes log. So r equals to 10 into log 2. But what is log 2? You are given in the question itself. 0.6931. This is to the base e. Remember, आपके पास जो log table होता है उसमें base 10 होता है. Remember, so it's different than what you know from the log table. So r equals to how much we are getting? This into 10. So 6.391%. This much is the rate of interest. Then in 10 years 100 becomes 200. Fine, very nice question. Remember, I just repeat the entire solution. See what I did. First I formed this condition. From the condition I formed this differential equation. Then we have just solved it. Log p I written here instead of c log c. Remember, then we have just simplified and I've expressed in form of this exponential function here. Then initially you had 100 rupees. After 10 years it becomes double, so 200. So I've used these two conditions and we got the value of r, that is 6.391. Initially always we take t equals to 0 and we'll get the constant of the integration. You just refer the question number 19 also. There also you have used the same condition. Question number 22 I'll do, which is also an important example. Just read the question. At the end, if you see, if the rate of growth of bacteria, so change in the bacteria, so I'll take x equals to number of bacteria at any time t. Fine. Now here what's given to you? Rate of growth of bacteria. So you are given that change in the bacteria with respect to time. Growth of the bacteria means change of the bacteria is proportional to the number present at that time. What's the number present at that time? That is x. Rate of growth of the bacteria is proportional to the number present at any time t, right? So dx by dt is proportional to x. So you can say that dx by dt equals to kx, where k is a constant of the proportionality. Okay, now you can see that this is a differential equation and we solve it. I'll solve this. Take x down here. So dx by x here equals to k dt. This is which form? Vs form, variable separable form. Now we integrate it. So we integrate it. So here you have integral of 1 upon x with respect to x equals to k. You can take outside because it's a constant 1 dt, remember. So this is log x equals to, here k as it is, integral of 1 is t plus, as I did in earlier two questions, we write the log c as a constant, not just c. I'll take log x over here, so I'll get the log x minus log c. So x by c equals to kt. Here remember c is a constant of the integration, as we know, arbitrary constant. Drop the log function, so x by c equals to e raised to kt, and therefore x equals to c into e raised to kt. This is our main equation number 1, remember. Why I have exponential here? Why I have exponential here? Because here nothing is given, means base is e, remember. So when you drop the log function, you have exponential function. You know, log y equals to x to the base e. It implies y equals to e raised to x. Right? This is what we have. So this is nothing but required solution of the given differential equation. Every time we normally express in form of exponential, remember. Now what are the unknowns? There are two unknowns, c and k. So as we did earlier, we tried to find the value of C as well as K, remember. Now let's read the question. Bacteria count was 1 lakh. The number is increased by 10% in 2 hours. So initially we had 1 lakh bacteria, remember. So we write, as we have written, if t equals to 0, let me write, if t equals to 0, that is in the beginning, the number of bacteria, that is x, which is given by 1 lakh, that's given by how much? 1 lakh. Let's use this. So by 1, you will get here 1 lakh equals to C into e raised to 0. So you'll get the C, which is 1 lakh. Fine. You got the C now. As you did in the previous question, there also you were getting C. If t equals to 2 hours, in 2 hours, the number of bacteria will be increased by 10%. So you have 1 lakh plus 2% of 1 lakh. 2% of 1 lakh, remember. So it will be how much? 2%, it is 10,000. So here we'll get 1 lakh 10,000. Fine. That is number of bacteria after 2 hours, remember. Fine. Okay, so we use this again in 1. So by 1, let me use that, 1 lakh 10,000, that is equals to C. Just look at it 1, remember. 1 pe dekho. What is C? That is 1 lakh. Fine. Into, what about this here? E raised to, you will get at this place K into 2. Fine. So this 4 zeros will get cancelled here. Remember, this is 1 lakh. So 4 zeros will get cancelled. So you will get the 11 equals to 10 into e raised to 2k. Fine. Now I'm interested to get this K, remember. Is it? C you got. C is here. So I can write here, how do I write? At least 11 by 10 equals to e raised to 2k. So you can just take the square root on both the sides. 11 by 10 raised to half equals to e raised to 2k raised to half. So this 2 will get cancelled. So 11 by 10 whole raised to half equals to e raised to k. So you got the e raised to k now. Instead of k, you have e raised to k, and here you have c. So therefore equation 1 reduced to, therefore equation 1 becomes finally x as it is, c it is 1 lakh, here I'm just placing the value of e raised to k, remember. What is e raised to k? That is 11 by 10 raised to 1 by 2, and raised to t is there, remember. So here t as it is. I hope this is clear to you. I repeat, what I'm doing, I'm placing the value of c and k. C you already placed, which is 1 lakh. I'm placing the value of e raised to k, remember. T power, in the power t is already there, right? And power of the power gets multiplied. So here you will get the 1 by 2 into t. Now the question is, remember, what's the question now? In how many hours the count becomes 2 lakhs? That's the question. This is final solution, remember. This is sometimes called particular solution. Now we are going to answer the question, remember. So question is, if x equals to 2 lakhs now, 2 legs, then what's value of t? That's a question in how many hours. So that we are answering now based on this equation. You can call this as equation number 2, for example. So by 2 now I'm answering. So by 2, x is 2 legs. On the left hand side you have 2 legs. Right hand side you have 1 leg into 11 by 10, 1 by 2, and in 2 hours, remember. So here t you want, that's a question. So here you will get just 2 equals to 11 by 10 raised to, you have half into t. The question is get the t. I'll apply log on both the sides. So log 2 equals to 1 by 2 into t will come in product, and you have log of 11 by 10. So log 2, this will come down, which is log of 11 by 10 equals to half into t. And therefore t I'll take over there, 2 into log 2 upon log of 11 by 10 equals to t. This is the required time. If t equals to this much hours, then the count will be 2 legs, remember. Let me repeat this portion. By 2, x is 2 legs. This was already there. Look at it 2. 11 by 10 half. T you want. So we keep this t as it is. You want the time, remember. So here all zeros will get cancelled. This is 2. Now I want the value of t. So I want to drop this exponential function. This is in the power, remember. So I need to apply log. Okay, so here log 2, if you have here, something raised to x, when you apply the log function, x will come in product and you have log of this expression, So this will be in the product and you have log of this. This is the property of the log function. Then I'll take this down and make the t as a subject of the expression. Fine? Question number 23, dy by dx equals to e raised to x plus y. So I can rewrite like this. Fine, just separating powers. Now variable separable form. I'll take e raised to y down. So it will be e raised to y minus y dy equals to e raised to x dx. This is which form? Vs form. Just rearranging terms about variable x with dx, terms about variable y with dy. Now you integrate it, just integrating. What's the integral of e raised to minus y? E raised to minus y upon minus 1. So this is minus sign equals to e raised to x plus c. So you will get e raised to minus y, I'll take this one over here, plus e raised to x equals to minus c, remember. But minus c or plus c is not important. You can write here c dash new constant, and therefore a is your correct option. Here one more time, if I take this term over here and c on the other side, it becomes minus c. But minus c or plus c is not important because this is any arbitrary constant, and therefore as per the options, a is correct answer.